Today we're going to talk about ocean currents. We'll talk about what causes currents and also the different types, and then how those currents affect climate. There are a few important things to understand when learning about ocean water. One is that ocean water never stands still. Ocean currents are like rivers that move within the ocean, and this movement does influence the surrounding climate. So why is ocean circulation important? Well, it transports about 20% of the heat that makes it to the equator to the poles. It also transports nutrients and other organisms. It influences weather and climate, and it influences commerce. This shows a non-rotating Earth, and this is what the flow of heat would look like on the Earth if it was not rotating on its axis. So you can see that the equator gets heated more directly, and so it's hot there. And then what we have is that air would be rising, and then the colder air and colder water from the poles would be moving towards the equator. But when we add rotation and land masses into our model, we end up with very unequal heating and cooling of the Earth. There are two main types of ocean currents. We have surface currents and deep water currents. Surface currents are the upper 400 meters of the ocean, so just really the upper 10%. And then deep water currents are the other 90%, which are also called thermal currents. Surface currents are caused by the wind and usually move only the upper few hundred meters of water. These currents do not move in straight lines. They are affected by the Coriolis effect. So surface currents in the northern hemisphere curve to the right, and surface currents in the southern hemisphere curve to the left. These are three forces that affect surface currents. They are mainly driven by the wind, but these winds are affected by solar heating, by temperature and density differences, and then also the Coriolis effect has a great impact on surface currents. Here we see those surface currents, a map of all the surface currents on the Earth, and you can see that there are some warm currents, which are red, and some blue cold currents, and the warm currents are currents that originate from the equator and move poleward, and so they're taking warm water north or south, and then the blue cold currents are originating towards the poles and bringing that cold water towards the equator. So take a moment now to color the world map that you were given in class with these different currents on there, and color the warm ones red and the cold ones blue. So to recap, those surface currents that occur in the uppermost 100 meters of water are wind-driven. Our deep ocean currents are driven by density differences, and so we see very, very slow movement, very slow flows in deeper waters. A few examples of surface currents that you'll see on your map are the Gulf Stream, which originates near the equator and travels up the east coast. This is a warm current. And the California current, which originates towards the north and travels down the west coast, is a cold current. The Coriolis effect is the result of the Earth's rotation, and this causes any objects that are moving to follow curved paths. So again, in the northern hemisphere, we see objects curving to the right, and in the southern hemisphere, the curvature is to the left. This does change with latitude, so there is no Coriolis effect at the equator, and we have a maximum Coriolis effect at the poles. The effect of the Coriolis is a deflection of anything that's moving. The object doesn't actually deviate from its path. It just appears to do so because the motion of the Earth underneath it. We see this Coriolis effect on the Earth because as the Earth rotates, different latitudes are traveling at different speeds, and the change in speed with latitude causes a Coriolis effect. So here's a good example of two cities, Buffalo and Quito, which are at the same longitude, but you can see here that Buffalo would be moving at 783 miles per hour, while Quito would be moving at over 1,000 miles per hour. So another thing we need to take a look at is how do surface currents affect climate? So I want you to think about a couple of questions. First of all, well, what is climate? Climate is the pattern of temperature and precipitation typical of an area over a long period of time. So then how do surface currents influence climate? This is something that we'll talk about a little more in detail in class, but I want you to think about a few different things. First of all, keep in mind that a surface current can warm or cool the air above it, depending on what type of current it is. So warm currents will warm the air above it, and cool currents can cool the air above it. So this can influence the climate of the land near the coast. The oceans influence climate over both long and short time periods. The oceans and the atmosphere are tightly linked and together form the most dynamic component of the climate system. The ocean plays a critical role in storing heat for the Earth. Ocean waters are constantly being moved about by powerful currents, and these currents can influence the climate by transporting heat throughout the Earth. So think about those things, and we'll study the exact effects on climate in more detail in class. Now we're going to take a look at the other types of currents. These are our deep ocean currents. Sometimes these are called density currents because they have everything to do with density. So we need to think about what factors affect density and the density of salt water. These currents occur when more dense seawater sinks beneath less dense seawater. And seawater can become more dense when it gets colder or becomes saltier. It's going to be these two factors that are going to affect density, salinity and temperature. It's this movement of this more dense water sinking and the less dense water rising that causes the currents. Cold, salty water is very dense, so it sinks and slowly floats southward along the ocean floor. Deep currents are crucial to the base of the world's food chain. As they transport water around the globe, they enrich carbon dioxide, poor, nutrient-depleted surface waters by carrying them through the ocean's deeper layers where those elements are abundant. Because deep in the ocean we have a lot of carbon dioxide storing there and a lot of nutrient storage as well. These nutrients and carbon dioxide from the bottom layers that are distributed through the upper layers enables the growth of algae and seaweed, and these things ultimately support all forms of life in the ocean. These deep ocean currents also help to regulate temperatures. One process that happens in the ocean is called upwelling. This is kind of like a current that in the ocean that brings deep cold water to the ocean's surface. Surface winds blow parallel to the land because of the Coriolis effect, and because of those winds blowing, cold deep water continually replaces the surface water that's pushed away by those surface winds from the coast. This upwelling brings up phytoplankton, zooplankton, minerals, and other nutrients from the ocean floor. Here we see something called the Great Ocean Conveyor Belt, and these are the deep ocean currents that we see where we have that very cold, deep, very dense water moving on the ocean floor, and then the warmer water above it rising. And so we have what we call the Great Ocean Conveyor Belt. And here we can see kind of another picture where we have thermohaline circulation, and this is again just that deep water flowing on the bottom, very dense water, and then it rising above it. One very important climatic effect of deep ocean currents is something called El Niño. El Niño is a warm surface current in the equatorial eastern Pacific that occurs periodically around Christmas time, every 2 to 7 years. The southern oscillation is the resulting change in the atmosphere above the area of the Pacific Ocean. And ENSO is a combination of the two, a combination of the oceanic effects and the atmospheric effects. El Niño is something that happens in the Pacific Ocean, so let's take a look at the normal conditions in the Pacific Ocean. So what we see here, if you kind of take a look at where we're at here, we have North America here and South America here, and what we have happening here is deep in the Pacific Ocean, we have that cold water along the bottom, and along the coast of South America, we have some surface winds here, indicated by the green arrow. And because of those surface winds are moving the surface water there, what we typically have happening is that what we just talked about, upwelling. So that cold water comes up to the surface here. So at the surface, in the eastern Pacific Ocean over here, we have cold water. And that moves westward across the Pacific Ocean over here, where it warms up as it travels along the equator. And so in the western part of the Pacific Ocean, we have warm water there. And as a result, the atmospheric conditions here is we have high pressure in the east and low pressure in the west. And so high pressure means that the air is sinking. Low pressure means that the air is rising. And because we have this warm, moist air rising, we typically have lots of precipitation, warm precipitation events over here in the western Pacific. So those are normal conditions in the Pacific Ocean. So take a moment in your notebook to color in the handout that you have for the normal conditions. So you're going to color the warm areas red and the cold areas blue. Please be sure to include not only the warm and cold areas on the surface, but also those deep ocean waters as well. And include the arrows that you see showing the movement of the current, and also that you can use a different color. You can use green or any other color to show the circulation in the atmosphere, and also include this little cloud here with rain so we know where the precipitation is happening. Now let's take a look at El Niño conditions. So we're going to look at the oceanic and atmospheric phenomenon that we see. This typically occurs in December, so towards the end of the year, and we see kind of a 2 to 7 year cycle, and it's not very predictable. It's 2 to 7 years is kind of a wide range, and scientists aren't exactly sure what causes it. There's a lot of different theories out there. But what we see are changes in sea surface temperatures, atmospheric winds, and upwelling. So here we have our El Nino conditions, and we call this a warm phase in the atmosphere. So what you see happening over here is we don't see that upwelling happening along the coast of South America. And so that has an effect on the fishing business there, because without the upwelling bringing all the nutrients up to the surface, not as many fish are there. So this definitely affects the fishing industry when it's an El Nino event. So what we have happening here is the warm water does not stay over here in the west. Because we don't have the upwelling and the cold water pushing across the Pacific Ocean, that warm water moves the other way across the Pacific Ocean. So the current changes a bit right along the equator there. And because of that warm water moving eastward, now we have low pressure in the east and high pressure in the west, which is opposite what we have during normal conditions. And with this low pressure, that means the warm, moist air is rising, so that those precipitation events shift to the eastern Pacific instead of the western. So take another moment now to color in the warm water and the cool water, which here we just have along the bottom of the ocean, and also add in all of the arrows and the precipitation events as well. So here we have something called La Nina conditions. So it's called the ENSO cool phase. So while El Nino is a warming phase, La Nina is a cooling phase. So this is the opposite of El Nino. So just like during normal events, we do have upwelling, but we have even more upwelling. And so what happens is that cold water pushes a lot further towards the west than it typically does. So we still have that warm water rising. We still have the precipitation over here, but we have much cooler weather over here on the east than normal conditions. So take another moment now to pause and to color in your La Nina handout. So here's just a nice map showing ocean surface water temperatures. So we see during the non-El Nino event, we have fairly cool temperatures over here off the coast of South America. And if we look during El Nino events, we have a much warmer current here happening and flowing eastward towards South America. This one is showing the different, the deep ocean currents and the deep water that we have here. So in a non-El Nino event, you see that we have the upwelling of the cool water off the coast of South America there, and that warm water stays western. And during an El Nino event, that upwelling is blocked, and that warm water pushes over towards the eastern side. This is a nice graph of the El Nino events over the last 55 years. The blue areas show cooling events, so those are La Nina events, and the red ones are the El Nino events. And what's interesting is that if we look in the past 20 or 30 years, we have a lot more instances of the warming events than cooling events. And this is alarming to a lot of scientists and still a little hard to explain. A lot of people do think that it goes hand in hand with global warming. So what are the effects of El Nino? Well, we see lots of effects on weather patterns and marine life and economic resources. During an El Nino event, when that upwelling is prevented, it really affects the fishing industry, like I said. And then also we see a huge change in weather patterns. We see off the coast of North America in the California area and off the coast of South America. During the El Nino events, we see a lot of flooding and a lot more precipitation than what we're used to. Here, this is a really nice visual of some effects when we have really severe El Nino events. So we can see areas where marine life is impacted, where we have some flooding events, lots of coastal erosion, and so that's happening over here in the eastern Pacific. But on the western Pacific, we see that there's quite a lot of drought and forest fires because they don't get the rain that they're used to seeing during normal conditions. So that's it for Ocean Currents and Climate. Please make sure that you rewatch the video if you need to and that you get plenty of notes.